This is section 3.2 of MA 104. We're going to look at problems 21 through 31 odd. For the first few problems, we are asked to sketch the graph of a continuous function over the interval -5 to 5. That would be the domain interval, so the x's. We want a graph of a function that is consistent with the given information. So for number 21, the function has to be increasing on the interval from -5 to -2, constant on the interval from -2 to 2, and decreasing from 2 to 5. Keep in mind that these intervals represent the domain variables, or the domain intervals, and also that it's possible to have several different outcomes here, or several different sketches. The important thing is that the sketch meets all of the conditions. So the first thing we want is a piece of that sketch that is going to be increasing between -5 and -2. So I need a point somewhere that's -5 something. It doesn't really matter what it is, just as long as the x-coordinate is -5. And then I need a y-coordinate that's -2 something. And I need to make sure that when I connect those points, that the function would be increasing. And it is. As I move from left to right, the function is moving up. Then I need my function to be constant between -2 and +2. So wherever your point was that was -2 something, you want your point 2 something to be that same y-coordinate. So in other words, when you connect those points, your function, well, that might not look perfect. Let's try that again. I just want that to look a little bit better here. So let's try that again. We want the point to be 2, that same something, but we want to make sure that when we connect those points, our function is constant. It's not moving up or down. And then finally, we want our function to be decreasing between 2 and 5. Again, your point should be 5, something. It doesn't really matter what, as long as when you connect it, it creates a section that is decreasing. So you can see that this function is increasing between the domain values, or the x values, of -5 to -2. It's constant between -2 and +2, and it's decreasing between +2 and +5. Next, we want that same idea. We want to sketch that continuous function. This time we want our function to be decreasing between the x values of -5 and -2, still constant between -2 and +2, and decreasing between +2 and +5. So since I want the interval to be decreasing between -5 and -2, I'll find -5 something. We'll start pretty high since the function's mostly going to be decreasing. And then I need -2 something. It doesn't really matter what, as long as when I connect those points, my function is decreasing. As I trace it from left to right, it's moving down. Then between -2 and +2, my function should be constant. It should not be moving up or down. And finally, between 2 and 5, I can create another point that's 5, something. Doesn't matter what your y-coordinate is, as long as when you connect that previous coordinate that was 2 something, your function is decreasing. For this one, again, we want that function to be decreasing between -5 and -2. So again, I will find -5 something and -2 something. It doesn't matter so much what the y-coordinates are, as long as connecting them creates a function that is decreasing. My function should be increasing this time between -2 and +2. So I need a point that's -2. I have a point rather that's -2 down here. Then my point that's 2, something should be up a bit so that when I connect them, the function's increasing. And then finally, we want it decreasing between 2 and 5. Let's make this one decrease just a little bit, just to show you that it doesn't have to be a drastic decrease, as long as the function's moving down. For these problems, we're asked to find the slope and intercepts and then sketch the graph. Well, the function f of x equals 2x plus 4 is the same as the function y equals 2x plus 4. f of x takes the place of y. F of x represents the range variable. So if I rewrite this as y equals 2x plus 4, we can see that this is a function in slope-intercept form. It's a linear function in slope-intercept form. We know from the function being in slope-intercept form that the slope will be whatever the coefficient of x is. So the slope of this particular function is 2. The y-intercept is whatever is being added onto the end. So in this case, my y-intercept is positive 4. To find the x-intercept, I have to do a little bit of calculation. I have to let y equal 0. So instead of saying y equals 2x plus 4, I'll say 0 equals 2x plus 4. Solving that gives me negative 4 equals 2x. Dividing both sides by 2 tells me that negative 2 equals x. So my x-intercept is negative 2. Now remember, the y-intercept being 4 means that the point 0, 4 is a point on the graph. The x-intercept being negative 2 means that the point negative 2, 0 is a point on the graph. These two numbers don't have any relationship to each other beyond the fact that they're both intercepts. They're each a separate point. To sketch this graph, I can find my y-intercept, which is positive 4. I have a couple different options here. I could use the fact that the x-intercept is negative 2 and just connect those 2 points. Or I could verify that these work by using the idea that the slope is 2. So from either one of these points I can go up 2 and over 1. Up 2 over 1. Up 2 over 1. And you'll see that you do hit those points. So I could even create another point if I wanted to and sketch that graph. For number 29, I can rewrite this function as y equals negative 1/2 x. Do a little bit better job with that. Y equals negative 1/2 x minus 5/3. Well, again, because it's a linear function in slope-intercept form, the slope is the coefficient of x, so the slope is negative 1/2. The y-intercept is whatever the constant is. In this case, it's negative 5/3. And then to calculate the x-intercept, I can let y equal 0, so that gives me 0 equals negative 1/2 x minus 5/3. I can add the 5/3 to both sides to get 5/3 equals negative 1/2 x. Solving for x means dividing both sides by negative 1/2, which is the same as multiplying by negative 2. So negative 10/3 equals x, which means that my x-intercept is negative 10/3. Using this information, if I find negative 5/3, I can graph it. If I find negative 5/3 on the y-axis, negative 5/3 is negative 1 2/3, so I'll be right about there. And then my slope is negative 1/2, so from there, go down 1 and over 2. So this will give me an approximate look at my graph. To look at the function f of x equals negative 2.3x plus 7.1. Again, I can rewrite it as y equals negative 2.3x plus 7.1. My slope is still the coefficient of x, so that's negative 2.3. My y-intercept is still the constant, which is 7.1. My x-intercept would be what I get when I replace the f of x, or the 0, with a y, with a 0. So I get 0 equals negative 2.3x plus 7.1. Add my 2.3x to both sides, gives me 2.3x equals 7.1. Divide both sides by 2.3. and we get x 7.1 divided by 2.3 is about 3.1. So we can say it's about 3.1. So my x-intercept is approximately 3.1. Find the y-intercept on the graph. So find the number 7.1 on the y-axis. Let's see, 7.1 might be right about there, a little bit above the 7. My slope is negative 2.3, so that's the same as negative 2.3 over 1, which means my rise would be negative. I'm going down. So I would go down 2.3, so maybe something like right here, and then over 1. Erase that. If I connect these, here's the approximate graph of my line. You can see that graph does appear to cross the x-axis at about 3.1, so we even calculated the x-intercept correctly.